Good afternoon, sir. Yes, good afternoon. Can you hear me? Anyone?
Yes, good afternoon, Professor.
Hello.
Good afternoon, sir. Hello. Professor.
Can you hear me?
Yeah, Mr. Brito, good afternoon. Now you are audible. Hello, Brito. Say again. Hello.
Hello, sir. Can you hear me, sir?
Yeah, I can hear you. You have
Yes,
to
sir.
speak closely from the mic, I think. So it's coming.
Yes, sir. Okay.
You go ahead. You start off.
Yes, sir. Okay. So good afternoon. So you know the syllabus of IMUCET examination. This is a general syllabus for this. English, you have total 200 marks. So English, you have 25 marks. Then GK, you have 25. General aptitude 25. Physics 50. Mathematics 50. And chemistry 25. So in this, I'm going to take mathematics, which we have 50 marks, which is allotted. The syllabus they have given us +2 state board and CBSE board. But sometime they may ask the basics also, not only 12th standard. 12th standard you may use some topic which you are not studying 12th standard also may come. So I frame the syllabus based on the sample question. Because this is a syllabus for mathematics. So today we'll discuss since we have a lot of topics are there, but we cannot complete in one class. Whatever you cannot complete. So we'll try to cover all the concepts of all these, not only all, but 5 or 6 concepts we can cover first. So these are the syllabus for mathematics. First is AP, that is arithmetic progression, then geometric progression, permutation, combination, then matrices and their application, this second chapter. Then trigonometry and complex numbers, then analytical geometry of 2 dimension. The basic analytical geometry also you should know. Then analytical geometry of 2 dimension and some 3 dimension, some topics also you should remember. Then vector algebra, analytical geometry of 3 dimensions. Then differential calculus, integral calculus and its applications, differential equations, probability distribution and discrete mathematics. So this is a syllabus. This is combined of both state board and CBS, right? So the first thing we have the AP GP. The AP GP actually is not in the 12th standard syllabus, but you study in a lower classes. So some question may come in AP GP and permutation combination. These are the basics also. You may use this AP GP or permutation combination in probability and some other topics also in it. So what is AP? So AP means arithmetic progression. What is arithmetic progression? Anyone know what is arithmetic progression? Arithmetic progression. See, arithmetic progression is a series of number. For example, no, 1, 2, 3, 4, etc. A series of number in which the difference between two consecutive numbers is equal. Then the series is called AP. That is arithmetic progression. Now look at the example 1, 2, 3, 4. Here the difference is 1. The difference between 2 and 3 is 1, and 3 and 4 is 1. So in a series of number in which the difference between two continuous numbers is equal, then the series is called arithmetic progression. They are in AP. So we can write your own example also. Right, 2 or 4, 6, etc. Here also look at that. The difference is what? Equal. So it is an AP. So in AP, you should remember some formulas. The question come based on the formulas. One is that suppose you have a AP number is given. That the number, what is the 10th term of this AP? So here the numbers are 1, 2, 3, 4, 5. So you know you can easily tell 10th term is what 10. But if the numbers are different numbers, different the intervals are different, we cannot find easily. So we have a formula of finding the nth term, which is Tn is equal to A plus n minus 1 into D. So this is a formula for nth term, to find the nth term of GP. So surely question come find the 50th term of some series of numbers. So you can put n equal to 50. Then here we are using the two term which is A and D. So what is A? A is the first term. A is the first term and D is called the difference. So A is a first term. D is called difference. If you know the first term and difference, you can form the AP yourself. Suppose you have the first term is 3, then the difference is minus 1. So you can form a AP. So the AP is first number is 3. Then you add the difference 3 minus 1, which is 3. Then add the difference, so which is 1. Right? Then you can add the difference, that is minus 1, which is 0. Right? You can keep on writing. So if first number and the difference is given, you can form yourself the AP. So if you know what is A, what is D, you can find the nth term. So the formula of nth term is A plus n minus 1 into D. So remember this formula, it is very useful when you do a problem. Then another formula in AP is the nth sum of n term. Suppose you are given the series like this. Suppose you have 1, 3, 4, up to suppose 10. What is the sum of the number from 1, 2, 3, 4 up to 10? But this, since it is the numbers are easy, you can find manually. But some numbers may be, the series may be difficult, so you cannot find the sum easily. So we use a formula that is Sn is equal to n by 2 into 2a plus n minus 1 into d. So this is a formula of finding the sum of n terms. So in AP, two things you should remember. No problem. One is the nth term formula, that's Tn. Then sum of n term formula, which is Sn equal to n by 2 to a plus n minus 1 and 2. You know what is n, what is a, what is d? So a is called the first term, d is called the difference, and n is the number of terms. So if you know all this, we can find the nth term and sum of n. Okay, you understand? So this is what AP. So question come from AP, right? So now next we will go GP. So what is GP? It's okay. So GP is a number of term which is that in AP, you know the difference between the term is equal. Consecutive term is equal. But in GP, the difference between two consecutive terms, not the difference, the ratio between two consecutive terms is equal. For example, you have a number 2, 4, 8, then 16, comma, etc. So these numbers are in GP. So GP, what I said, see the different the ratio between there is 2 4 by 2, which is equal to 2. Then 8 by 8 by 4, which is also 2. Then 16 by 8, which is also 2. So in a series of number, the difference between any two, sorry, the ratio between any two consecutive numbers are equal. then the series is called GP, right? So the GP is this. So example, we can say many examples. One example is what? 2, 4, 8, 16. Here also we are using first term and instead of difference, we are using here the R. So that is R is we are using A is the first term. Here the first term is 2. Then we are using R, which is called ratio. So the ratio is nothing but this 2. So if you know the first term and the ratio, you can form yourself the GP. So GP also you should remember the two formulas. There is nth order, nth term formula and the sum of n term formula. These two, okay, you got to remember. So this is Tn is for AP. This Tn, there is A plus n minus 1 and D, then Sn n by 2, A plus n minus 1. So this is for AP. For GP, this. So for GP, A is a first term, then R is a ratio, this common ratio between the consecutive term. So we can find, we can write the formula of nth term of GP, which is Tn is equal to A into R power n minus 1, right? So the nth term of GP is A into R power n minus 1, where A is called first term, R is called the ratio, n is the number of terms. Like in GP also we have a n term formula, that is Sn is equal to 1 minus A power n divided by 1 minus A, which is if the A value is what? Here less than 1. But this question rarely comes as finding the sum of n term, but we should remember the nth term. As question come based on the finding the nth term. So remember the sum of n term also. Sometimes they may ask. So Sn is equal to 1 minus A power n divided by 1 minus A if A is less than 1. A power n minus 1 divided by A minus 1. The A is greater than 1. So this is for GP. Then you should know the permutation. So you know what is AP, what is GP, you know. Next one is a permutation. So what is permutation? Permutation means permutation is called arrangement. The combination is called selection. So you are arranging a number in an order or arranging an object in an order. Then it is called permutation. Combination means selection. So here we are using the formula. There is NPR and NCR. So NPR means from the n number we are selecting R. So this NPR we are writing the formula n factorial by n minus R factorial. This is permutation. So remember, permutation means selection, permutation means arrangement, combination is selection. So NCR formula is n factorial by n minus R factorial into R factorial. You know what is factorial? So 3 factorial, you know 1 into 2 into 1 into 2 into 3, right? This is 3 factorial. So remember the formula. I don't want to go deep on this. So remember what is AP, what is GP, what is permutation and combination. Because we are going to use these things in probability also. Some other in analytical geometry, but trigonometry also sometimes you may use this permutation combination. Okay, so we should remember this basic concept. So the next topic we have matrices and the application. So what is a matrices? See, matrices, you know, what is a matrix? It's arrangement of rows and columns, right? Arrangement of rows and columns are called matrices. Another one is called determinant. So you should know what is a matrix, what is a determinant. Matrix means simply arrangement of rows and columns. But determinant also the same, but determinant has a value. And matrices, there is no value for matrices. Matrices means you can add the two matrices, you can subtract, you can multiply. But determinant means can find the value. So you should know the difference between the matrices. First, there's a basic, really question may come. What is a singular matrix? Singular matrix means determine value. Suppose you are finding the value of the matrix, the determined value. If you are getting the 0, then it is called a singular. So you should know the difference between matrices. Determinant we use a bracket like this. Matrix we use a bracket like this. Right? Determined always a square matrix. Should be a 3 cross 3 or 2 cross 2 or 4 cross 4 like that matrices. Then only you can expand it. But matrices need not be a square matrix. It can be any. So remember, right? The singular matrix. The singular matrix is the determinant value. If the determinant value is 0, then the matrix is called a singular matrix. Non-singular matrix is the reverse, right? If it is not equal to 0, then it is called the non-singular matrix. So remember what is singular, what is non-singular. Based on the singular, non-singular, we may do a lot of problems. So my problems may come. Next one, inverse matrix. So inverse means you should know what is the determinant of a matrix, how to find a determinant matrix that you know, expand the determinant by any other row or any other column. So you find first determinant of a matrix, then find the cofactor of matrix. After cofactor, you find the adjoint matrix. Then you can find the A inverse. The formula of A inverse is 1 by mod A into adjoint A. Right? These are all you studied. A lot of problem you have done, so no problem. No need to. Just I'm recalling all the concepts. If you want to just take a note. So this is what inverse of a matrix. Then the properties are determinant. So you should know the properties because when you do a problem, you may use these properties. I said what is a determinant? Determinant is put in the bracket like this, a modulus bracket. The determinant has a value, right? The first property of determinant is the value of the determined value is not changed, not altered by changing the rows into columns, columns into rows. If you change the rows into columns, columns into rows, the value will not change. You can have a lot of examples, right? You can suppose you take right, have determined like this 1, 2, 3, 4. Then there is a if you change the rows, this should be 1, 3, right? Then 1. You find both the values should be equal. So if you find it, so 1 minus 6, which is minus 5. Here also 1 minus 6, which is minus 5. So if you change the rows into columns, columns into rows, the value never change. The values are equal. This is a first properties of determinant, which is very useful to a problem. Yes. Somebody somebody put in a silent mode. Sai Lakshmi. Okay. Right. So next question, next one. Second property is if the two rows of a determinants are interchanged, then the determined value will be one negative. The negative minus will come outside. This is the second property. Then the third property, the determined value is 0 if any two rows or any two columns are identical. If any two rows or columns are identical, then the value of the determinant is 0. It's the third property. But the first three property very important. It will go problem often. The remaining next three properties rarely we use, but you should know this. But the fourth property, if every element in a row or of a determinant is multiplied by the same constant k, and the value of the determinant is the k into the determinant. Right? So that constant can be in one row or any one column. If it is here, look at that here, KA1, KB1, AC1. So the K is in the first row. So you can take K as common outside. So this is the property. So suppose not only in a row, in a column also, if any constant is common, take outside. Then fifth one, any one row or any one column can be written as sum of two numbers. Then you can write that the determinant as sum of two determinants. See that? This alpha plus lambda, beta plus mu, then gamma plus mu means, then you can write it as what? Sum of two. Still correct. Not only in the row, the column also. If you return a two, any one column as sum of two numbers. Write the matrices sum of two matrices. Right? Then the last one, this any row or column can be multiplied by the scalar like this mb1, and you add the column and the value will be same. So I added here a1 plus some constant, some scalar in b1 plus some constant in c1. Then the same rule I'm applying for the entire right. Here we use, sometimes we may use a rule like this. C1, this is column 1. Column 1 implies column 1 plus some m into column 2 plus some n into column 2. This is a rule we are applying here. So if you apply a rule, then you are applying the rule for the entire column, not only the row. Suppose you are applying one row, you have to apply the for the entire row. So when you apply it, then you find the value of this determinant. That determinant value is equal to the given determinant. Both the determinant value should be same. So this is what the seventh property. So remember these properties are determinant, right? Sometimes for problem we use this properties, right? The last property rarely we use, so leave it. Then some more the concept of determinant. The Grammar's rule you should remember. This is a factor, but rarely we use. But the Grammar's rule you should remember. When you solve the equation, linear equation, we may use the Grammar's rule. So you may ask to solve the equation. For example, you have a 2x plus 3y plus 5z is equal to 5. X plus y plus z is equal to 1. Then x minus y plus 3z is equal to 5. What is the value of x and y and z? If they ask, you can use this Grammar's rule. Right? By using Grammar's rule, you can find the value of x, y, z. You can solve by linear equation method also. But instead of using linear equation method, if you use Grammar's rule, just here we are using, what is delta x? Delta x, you can write this matrices only the constant without the variable x, y, z. Then delta x means to change the first column with respect to this last value, change it, and you can find delta x. Delta means simply the determinant. There is 2, 3, 5, 1, 1, 1, then 2 minus 1. So this into x, y, z is equal to 5, 1, 5. By that you can write. So when you multiply, you can get the three equation. Solve this equation. You can consider this is what A, that is what delta. So you find the determinant of this value, that is delta. Delta x means you are changing the first column with that last column. Now for delta y, you change the second column with this. Then delta is change the last column with this. Then you get the value of delta x, delta y, delta z. Then divided by delta, you get the value of x, y, and z. Right? So the grammars also you should remember. So this is the concept in determinant we should remember. Apart from some more concept also may come, right? So you should be thorough, okay, all the concept of determinant, but this is most of the problem come in these concept of this. Just be thorough, this is enough. The next topic is trigonometry, right? We have, I said, APGP, permutation, combination, they are completed, then matrices and their application. Next one is trigonometry and complex number. So what is trigonometry? Trigonometry you studied from 9th standard onwards. What is angle? Okay. Then what is sine theta? What is cos theta? Sine theta means opposite side by hypotenuse. Cos theta, tan theta, secant, arc. So these are all you studied. Sometimes the question may come converting the degree into radian. There are two measures we measure on angle. One is the degree measure, another one is the radian measure. Right? So our Indian we use only degree measure. Foreigner they may use radian measure. You should know the difference between the degree and radian. There is a degree one radian is equal to pi. Pi is 180 degree equal to pi. So the pi is this, right? So these two formulas are relation between the degree and radian. Remember, sometimes question may come. So degree is equal to pi by 180 into radian, or radian is equal to 180 by pi into degree. Then the basic angle chart, you should remember when you do a problem, you may use these angles directly. So this chart, sin theta 0 degree 0, 30 degree 1 by 2, 45 1 by root 60 means root 3 by 2, then 91 180 0 270 minus 1, then 360 degree equal to 0 degree. Then the cos theta, we write the values from 90 to 0 degree in reverse form. Then tan theta is sin theta by cos theta. So you get the value of tan theta. Then cosecant is the reciprocal of sin theta. So you can get cosecant values. Secant is the reciprocal of cos theta. Get secant values. Then cot theta is the reciprocal of tan theta or cos theta by sin theta. You can get cot value. So if you remember these values, which one? That sin theta, cos theta. If you remember these values, you can find yourself the remaining tan theta, cosecant theta, secant theta, tan theta values by yourself, right? So this angle chart we should remember thoroughly because we may use when you do a problem, we may use this angle directly. Then the quadrant analysis also is sometimes we may ask to find the angle cos 120 degree. I think you are not allowed to use calculator. So you should find cos 120 degree directly. You should know what is cos 120. You can write cos 120 as either 180 minus 60 or you can write 90 plus 30. You can write, right?
Suppose
This is a quadrant analysis. So
it
these are
is
ready. Just
cos x,
start.
cos y,
So first quadrant, second quadrant, third quadrant,
plus
first quadrant, all the angles are positive. Second quadrant, sine only positive. Then third quadrant, tan positive. Fourth quadrant, cosine is positive, right? If the angle, if they ask cos B, it is nothing but cosine. So cosine in the fourth quadrant only positive, remaining the first quadrant also positive. Second and third quadrant it is negative. So when you ask to find cos 120 degree, correct? Cos 180 minus 60, which is converted to cos of 180 plus theta or 180 minus theta means then cos convert this what this angle chart. So cos 180 plus theta or 180 minus theta means cos remain cos. Then sin of 180 plus theta, sin 180 minus theta also sin remains sin. Tan also same. There is no changes if it is 180 plus or 180 minus and 360 plus 360 minus. So 180 plus or 180 minus or 360 plus or 360 minus theta means there is no change. Cos remain cos, sin remains sin, tan remains tan one. But when it is 90 plus 30 means cos change into sin change into cos, reverse. Tan change into cos change into tan. So like there will be a change. So here cos 120 how to find? You can write either 90 plus 30. If you write 90 plus 30, this will be sin 30. If you write cos of 180 plus 60, then this should be cos 60. Then look at the quadrant, it is 180 plus 60 means there is 120, it is the second quadrant. The second quadrant, sin only positive, this is cos, so it is negative, so you have to put get minus here, right? So minus cos 60 or minus sin 30, both values are same. Okay, you understand? So remember the quadrant analysis really when you not only in trigonometry, when you do the some other problem in the calculation, we may use this value, quadrant changes we may use. So remember this concept of quadrant analysis, right? If you have doubt, please unmute yourself and you can ask the doubt, right? Since we are okay, we have one hour, so I try to cover most of the topic. If you have doubt, please feel free, unmute yourself and you can ask the doubt, right? So this is the angle changes. Next, we have a trigonometrical formulas are there. Just note it down. First formula, trigonometric formula is sin square theta plus cos square theta equal to 1. Then 1 plus tan square theta equal to secant square theta. These formulas, there is 1 plus tan square equals secant square, 1 plus cos square equals secant. These are derived from the sin square theta plus cos square theta equal to 1. Then sin of a plus b formula, sin a cos b plus cos a sin b. Then sin of a minus b, sin a cos b minus cos a sin cos of a plus b. These formula also we should remember, sometime question may come. Just note it down the formula, trigonometric formulas of sum of two angles, sine of, then cos of, then tan of A plus B, tan A plus tan B, divided by 1 minus tan A tan B, then tan of A minus B is this. Then this very important formula, but the sine to A and cos to A. This is most of the time we may use this formula, sine to A formula. This to sine A cos A. Not with respect to tan, rarely we use, but with respect to sine and cos, sine to A, sine A cos A. This
Sine 2 theta is equal to
then
sine 2 theta is equal to 2 sine theta cos theta.
yes.
Cos 2
Cos to
theta
A equal to cos squared A minus sine squared A, right?
minus sine square theta.
Cos 2A is equal to cos
1
squared
minus
A,
2 sine square theta.
right?
2
Minus
cos
sine
theta.
squared A. In the place of sine squared A, if you put 1 minus, sine square theta plus cos square theta equal to 1. So instead of sine square theta, if you put 1 minus cos square theta, you get 1 minus 2 sine square theta. Instead of cos square theta, if you put 1 minus sine square theta, you can get this. So remember these formulas. There is sine to A, cos to A formula, not only cos to A, this formula, and 1 minus 2 sine square A and 2 cos square A minus 1 equal this formula in integration also. Right? Most of the time we may use very important sine to A, cos to A. Right? Then tan to A we use rarely, but remember tan to A is 2 tan A divided by 1 minus tan square A. Then sine 3A, cos 3A, then tan 3A. Suppose if you forget this formula, you can derive the formula yourself by using this sine of A plus B, sine of A minus B, cos of A plus B. By using these four formula, you can derive yourself these formulas, sine A, cos A, tan A formulas. Then another trigonometric formula, sine A plus sine B. 2 sine A plus B by 2, then sine A plus A minus B, cos A minus B. This formula also you should remember. Right? Even this formula also you can derive by using this formula. There is sine of A plus B, sine of A minus B formulas. So remember these trigonometrical formulas. Next one, trigonometric equations. Right? What is trigonometrical equation? In the equation, instead of the variable xy, there should be trigonometrical function. So sine theta equal to 0. It's a trigonometrical equation. Sine theta plus cos theta equal to 1. It's a trigonometrical equation. Any equation with respect to that variable is a trigonometrical function, then it is called trigonometrical equation. So these are the trigonometrical equation. General solution, we should remember when you solve the equation, we may use the general solution and particular solution. This is what general solution. Suppose you have here, sine, right, theta equal to 90 degree. What is the value of theta? If they ask, for what degree sine is, for what theta equal to sine theta is equal to 1, not 9. Sine theta equal to, what is theta mean? Then we say 90 degree. Not only 90 degree, so multiples are 90. That's why we are using the formula sine theta equal to 0 means, so we are using n pi. Because in the quadrant, it is not only 360, above 360 also the angle may come, right? So sine theta equal to 0 means not only 0 degree, it is 180 degree also 0. Okay, and 360 degree also 0. So this is general solution, right? Remember the general solution of sine theta equal to 0 and cos theta equal to 0. Question may come from this, right? Then general solution of cos theta is also 2n plus 1 into pi by 2, where n plus 2 is set. What is it said? It is at of all integers. So plus 1 minus 1, 0, plus 1 minus 2, plus 2 minus 2, plus minus 3. All this set of for all integers, this is satisfied. Then the general solution of tan theta equal to 0, this is same as sin theta equal to 0, which is n by n plus 6. Then general solution of sin theta equal to sin alpha. What is theta? It is n pi plus minus 1 whole n into alpha. So remember cos theta equal to cos alpha, then tan theta equal to tan alpha. But sin theta equal to 0, cos theta equal to 0, sin theta equal to sin alpha, cos theta equal to cos alpha. These questions may come, right? Solve the equation, question may come. So you should know the solution of. So there are two types of solution. One is general solution, another one is particular solution. This is general solution. Generally, we are calculating all the possible angles. Particular solution is only one solution, which is You can write either 0 degree or 180 degree. That's all, right? Okay. So remember the solution of trigonometrical equation. Next, inverse trigonometrical function. You know the inverse trigonometrical function, which is suppose we have sine theta equal to some alpha. What is theta? When sine go that side, it becomes sine inverse of alpha, right? So the sine go that side, it becomes sine inverse. So inverse trigonometrical function is also important one. So like cos theta, inverse of function is cos inverse, right? So in this inverse trigonometrical function, we may use the one formula often, that is tan inverse of x plus tan inverse of y equal to tan inverse of x plus y divided by 1 minus xy. Suppose if it is minus, then this should be minus, this should be plus. So remember the alternative formula also, right? So inverse trigonometrical function is only one formula we use, right? Solve a problem. Okay. Right. Next one. So trigonometry is a vast one. We are using trigonometry in right in integral calculus and differential calculus, even analytical geometry also. So remember the formula, basic formulas of trigonometry. Then relation between angles and sides, which we studied this 9th and 8th standard itself, right? If three, in a triangle, right? This is a triangle. This is a three angles, right? This is three sides. The angle we take capital A, this is capital B, capital C. The opposite to capital B is small b, which is side. Opposite to capital A, small a. Opposite to capital C is small c. So the small a, small b, small c, they are called sides. Capital A, capital B, capital C, they are called angles. So sometimes in a triangle, we may be given two angle one side. You are asked to find the remaining angles and sides. Then you should know the formulas, right? So the sine formula, Napier's formula, cosine formulas are used to find the missing angles and sides of a triangle. So in any triangle, remember the capital letters, capital A, capital B, capital C, they are denoted by angles. The small a, small b, small c, they are called, denoted by sides. Okay. So here you should remember some area of triangle formula also, which should come later. Okay. So remember the solving the triangle, sine formula, a by sine a equal to b by sine b equal to c by sine c equal to 2r, right? The same sine formula in mechanics is called Napier's formula, right? Sorry, Lami's theorem. Okay, we'll study later. Lami's theorem in physics, it is called sine formula. It is called Lami's theorem. So it is a by sine a equal to b by sine b equal to c by sine c, where a, small b, small c. They are called sides, capital A, capital B, capital C. They are called angles. Right. So remember just sine formula, Napier formula we use rarely. So, but here I have given, just note it down. Then cosine formula also you should know. Right. This cosine formula is used in a triangle, two sides and inner angle is given. To find the missing side, we use cosine formula. Right. Then half angle formula, projection formula. Okay, remember this. Then this is important one, the area, right? In a triangle, suppose this is a triangle. In the triangle, if three intersecting points are given, okay, if 3 points are given, x1, y1, this is x2, y2, so x3, y. If 3 points are given, then we have a formula of area of triangle, which is 1 by 2, which right formula here I am writing. See, 1 by 2 into x1 into y2 minus y3. This formula is not stated here, so question sometime may come. Plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is a formula. This formula is if the sides and angles are given, this is a formula area of a triangle, half and sine series. But if three intersecting points are given, x1, y1, x2, y2, x3, y3, like this, to find the area, we use this formula. half into x1 into half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y3. Remember this formula, note it down. This formula is not here. So this is what trigonometry that and a triangle, right? So the triangle in geometry also sometimes they use this triangle midpoint, centroid, center of then mid, midpoint, then in center, ortho center. In these places we may use question may come. So we should remember what is in center, what is ortho center also. Okay, this is what trigonometry. So next chapter is complex number. We are not discussing any problem. Okay, if time permits, we'll solve the problem later. Okay, we have problem set also. I have some sample question also there. First, we'll finish the concept, then we'll do one or two sample questions.
Arilla.
Yes. Next, complex number. This is a third unit, complex number. So the complex number, generally it's denoted by, the complex number is denoted by Z is equal to A plus IB, where the value of I is square root of minus 1, right? When you get the square root of minus 1, when we solve the quadratic equation, okay, some equation, we may get inside the square root minus 1. Inside the square root, if we get minus 1, this cannot be written. You cannot take minus outside. This is without by a letter I, right? So the complex number, number system also, natural number, whole number, integer, right? Rational number, then real, irrational number, real number, finally complex number, right? The complex number, we have numbers in this. One is A, another one is B. This A and B, they are called real numbers. They are called real numbers. A number system come in. So real number. In this A is called real part, the B is called imaginary part. Right? So remember the complex number A plus IB means then A is called real part, the B is called imaginary part. See, listen here, a number 2, suppose Z is equal to number 3 is also a complex number. But there is no I here. But right, this says 3 plus 0 I, where the imaginary part is 0, the real part is 3. So question, sometimes they may ask question, Z is equal to 3. Is it a complex number or not? So it's a complex number because you can write it like this. So any number, because that's why it said the number system of first natural number, then whole number, then integer, then rational number, then next is a real number. Finally, we have complex number. So all the numbers below the complex number, all are complex. So remember the number system. So in this complex number is the last one, which in general we are writing, right? A plus IB, where A is called a real part, B is called imaginary part. Right. Now, where I is equal, then if you find I square, the value of I squared is minus 1, then the value of I cube is minus I, value of I power 4 is 1. So you have done one chapter you studied. I think I think the CBSE don't study, I think, complex number. Not study, right? So remember complex number, question may come, right? So I is equal to minus 1, then I squared is these values we may use. Sometimes question may ask, they may ask, what is the value of I power 20? Question may ask. Okay, we may be given 4 answers, A, B, C, D, like this. What is the value of I? Okay, 20. Okay, right.
4 and 5.
So next one. Yes, the complex conjugate. No, A plus IB is a complex number. The conjugate is we are already A minus I. Remember, A plus IB is a complex number. The conjugate is A minus 2 plus 3I is a complex number. Then the conjugate of 2 plus 3I is 2 minus 3I. You are changing the sign of I. Okay. Then Z minus Z into Z bar is equal to A square plus B square. This also you should remember. Then the conjugate of Z bar is Z bar whole bar is equal to Z. This you remember. Then these properties Z1 plus Z2, right? whole bar is equal to Z1 bar plus Z2 bar. This you studied. Then Z1 minus Z2 whole bar is equal to Z1 bar minus Z2 bar. Then Z1 Z2 whole bar is equal to Z1. Actually, yes, it is right. This is Z1 bar into Z2 bar. Okay, right. So next one, the division, right? Z1 by Z2 whole bar. There is 4 bar means there is nothing but conjugate. So suppose you are writing 2 plus I. Bar means there is 2 minus I, right? So that's what okay, we are writing. Since the set means set bar means then we are changing the sign of I. Right. So remember these properties of right, complex number. Then triangle inequality is rarely we use. Then complex number we represent the complex number in an ordered pair. So suppose it is x-axis, y-axis. Suppose you take a number. This number we write actually a plus b, right? You can write this in the complex number. This is called the modulus, which we take as r. This is a point a. This is a point b. So we write this in the Cartesian coordinate. We write this point as a plus ib in the okay, coordinate point. This in the Cartesian coordinate we write this. We write a plus ib. The xy coordinate we can write this as a plus ib, right? Then we can find the r. So the value of r is nothing but root of a square plus b square. Then you can find theta. Okay. So here the theta is called argument. This r is called modulus, right? We'll see later. So r is called modulus. Then the theta is called argument. Or it is called amplitude, right? So the value of theta is nothing but tan inverse of b by a. So remember this formula, the modulus and argument question may come, right? Where the modulus is r is equal to a square plus b square. The argument, okay, or amplitude theta equal to tan inverse of b by a. What is a? What is b? You know, there is a is a real part, b is an imaginary part. Okay. Right. So this is what the complex number we represent in xy coordinate, right? The graph, Argand diagram, we are representing. Next, that's what I told you. What is the modulus or amplitude, absolute value, right? So modulus or absolute value means it is r divided by r, which is square root of a square plus b square. Argument or amplitude tan inverse of which is denoted by theta is tan inverse of b by a. Then these are properties. Okay, just read it. Question come. The argument of z is a unique, right? Argument of z, that is theta should be unique. There should be only one theta, right? Theta can be chosen infinite ways. Okay, I told you we already in trigonometry we study, when you solve sin theta equal to 0, theta equal to not only 0 degree, right? Sin theta equal to 0, theta equal not only 0 degree, it is 180 degree, then 260 degree. In all the places it is 0 only. Okay, but here they are telling theta is a chosen infinite number of ways, but it is a unique, right? Right. So remember these properties. Then argument, if sometime they may ask to find the argument. If the complex number is a plus ib, okay, then it is argument is the first quadrant. Minus a minus ib, which is argument is what? Phi minus theta, which is come in second quadrant. Both are negative. There is minus a minus b. So you can draw like this. See that this is here the point is a comma b. But the same point here is minus a because x coordinate negative minus a comma b. But here it is minus a comma minus a. Minus a comma minus b. Here it is a comma minus b. So based on this, you get a different argument. Remember this. When it is first quadrant, theta is the argument. When it is second quadrant, if a complex number is minus a, that is you can write minus 2 plus 3i. If it come like this, then find the theta and write the argument is pi minus theta, right? Because it is come in the second quadrant. Now, if both negative, If both negative, then it is in this third quadrant. Third quadrant minus of pi minus theta. Then next one is fourth quadrant. Okay, fourth quadrant, this is actually, sorry, this is minus, right? A minus IB, which is in the fourth quadrant. Then the argument is minus theta, right? So this is a shortcut. We have to remember to find the argument or amplitude of a given complex number. Okay, so the next one. Next is, these are some of the properties. Z1 is a complex number, R1 into cos theta 1 plus I theta 1. Z2 is another complex number, R2 into cos theta 2 plus I sin theta 2. Then product of the two complex number, we write R1 into R2, write the product of the two modulus function into cos of theta 1 plus theta 2. There is a proof or big proof you studied, but if proof no need, you just remember the concept, right? Like argument of Z1, Z2 is what? Theta 1 plus theta 2. Remember this, right, concept. Then you can write any number 1 as cos 0 plus I sin 0. Sometimes we may write the one in the form of cos theta plus I sin theta, which is cos 0 plus I sin 0. Then minus 1 you can write cos pi plus I sin 0, because the cos pi value is minus 1, sin pi value is 0. Then I we write cos pi by 2 plus I sin pi by 2. Minus I we write cos pi by 2 minus I sin pi by 2. These are the common general complex number. When we do a problem, we may use this. So that's why I given as a property. Remember this minus 1 minus 1, I minus I. Next one, De Moivre's theorem, right? Then n is any positive integer. Then we write cos theta plus I theta to the power n into cos n theta plus I sin n theta. The n come with the angle. So if n equal to 1 means, then cos theta plus I sin. If n equal to minus n, then cos n theta minus I sin n theta. So these properties, remember, especially the De Moivre's theorem, remember. Because by using De Moivre's theorem, question may come. Say in the place of n, if you put p by q, then the coefficient of theta should be p by q. Right. So these are some of the properties of De Moivre's theorem. Then remember the Euler's formula, e power I theta, right? The right e power I theta as cos theta plus sin theta. Any exponential form can be written as a trigonometrical function, that is cos theta plus sin theta, right? So e power, suppose if it is e power minus I theta, then it is cos theta minus I sin. So remember this also very important formula, Euler's formula. Yes. Next, solving next one. These are some properties of solving cubic root of unity, right? If it is a cubic root, we are solving x cube is equal to 1. Okay. Then for the root 1 omega square. If omega is minus 1 by 2 plus I root by 2, then their properties. Question may come again now. What are the property? What is the property of cubic root of unity? Right? It is 1 plus omega square equals 0. Omega cube equal to 1. So you should remember these properties. Then the fourth root of unity, remember, fourth root of unity means what? X power 4 equal to 1. This is x cube is equal to 1. This is x power 4 equal to 1. Then the solution is 1, minus 1, plus I, minus I. Right? Then these are some more properties. Remember, these are the important concepts of complex number. Right? Next topic is unit 4. It is algebraic geometry of 2 dimensions. Right? Algebraic geometry of 2 dimensions. Straight line you should remember. The equation of x-axis y equal to 0. The equation of y-axis x is equal to 0. Then straight line equation y minus y1 m into x minus x1, where that the m is called the slope. So this is a straight line. This is a x-axis y. This is a straight line. So this is a slope m. This is a line equation. So in the line, if we are given one point x1, y1, point is given and a slope is given, you can use this formula y minus y1 equal to m in x minus x1. So m is called slope. Usually slope is as a tan theta. right? Suppose if it is given theta, you can find the slope. You know what is the slope? The line intersect with x-axis. When the line intersects with the x-axis, which makes an angle, that angle is called a slope. Usually we denote the slope as smaller, right? So the first formula, the equation of straight line of a given a point and the slope is y minus y1 equal to x minus x1. Second one, the equation of the straight line of a given a slope and y-intercept. So this is if a slope and y-intercept is given, then the line equation y equal to mx plus c. Remember this one. This is a line, right? This is a slope m. Okay, this is y-axis. The line intersect with the y-axis. No, this is a point C, right? So this point is C. This is a slope m. So the slope m and the intersecting point y-intercept C is given. You can find the line equation, which is y equal to mx plus c. The first one is the point and the slope is given. This is a y-intercept and the slope is given. This is a line equation. Then third line equation is if 2 points of a line is given. Suppose this is a line. This is y-axis, this is x-axis, right? In this, you are given the 2 points x1, y1 and another point x2, y2, right? In a line equation, if 2 points are given, then you can find the line equation. The line equation is y minus y1 divided by y2 minus y1 equal x minus x1 by x2 minus x1, right? So remember, this is a basic formulas of straight line. Like we have another one, the slope y-intercept, x-intercept form. If a line intercept with respect to x-axis or y-axis, see listen here, this is the line. Intercept here at x equal to a, this is y equal to b, this x equal to a, y equal to b, then the line is x by a plus y by b equal to 1. So remember the third formula. The remaining, these are, they don't ask, rarely they may ask. These 4 formulas are important. This first one is general y equal to 0, equation of x-axis, equation of y-axis 0, 1 point and the slope is given. Then a slope and a y-intercept is given. Next one, 2 point is given. Then y-intercept and x-intercept is given with the line. So remember these formulas is very important. This is for one-dimensional geometry, right? The next, length of perpendicular from a point to a straight line. So this is length perpendicular, right? Here is a point x1, y1. Then this line is ax plus by plus c 0. This line is given and you are given the point. You are asked to find the distance between the line and the point. This distance, to use the formula, there is plus or minus ax1 plus by1 plus c divided by root of a square plus b. So you write this is capital A, capital B, capital C. This is A, right? A square plus b square. But sometimes instead of plus or minus, we use modulus also. Because the length never be negative, cannot be negative. So it should be a positive, so we use a modulus, right? So remember the length perpendicular from a point to the straight. Then the perpendicular from origin. Suppose this point is origin. Origin is 0, 0. Then the formula is c divided by modulus of c divided by root of a square plus square. Right? So let's recall these basic formulas are for straight line. Then intersection of 2 straight lines. Suppose 2 line is given to find the intersecting point. Then this is a formula. Then concurrent. Suppose there are 3 straight lines. There are 3 straight lines. They are concurrent, means they are parallel. When the 2 straight lines are parallel, you know that slopes are equal. You find the slope. Okay? Slope, no, the slope should be equal. When the 2 lines or more lines. When the 3 lines are they are parallel, then otherwise it is called concurrency. Then the determinant of this line, any line we write ax plus by plus C equal to 0. So one line is A1x plus B1y plus C1 equal to 0. Another line A2x plus B2y plus C2 equal to 0. Third line A3x plus B3y plus C3 equal to 0. Then these are the three lines, they are parallel or concurrent, right? Then the determined value should be 0. So remember this concept, right? When the three lines, they are parallel or concurrent, then the determinant of the coefficient of x, y, z can form a right determinant like this. Find the value should be 0. If you expand, you get this equation, right? Next one, remember the angle between the 2-point formula, right? Angle between two straight lines. One line is like this, one line is this, another line is this. This line you write y equal to m1x plus c, okay, this c1. This line you write y equal to x plus c2, right? m1, m2, they are called slope. If the two lines are given, what is the angle between the two straight line formula, which is theta equal to tan inverse of or less m1 minus m2 divided by 1 plus m1 m2. In the two lines, if the two lines are parallel, then their slopes are equal. The two lines are perpendicular, then the product of their slopes equal to minus 1. Right? So remember, this also part one. Product of their slopes equal to minus 1 when the two lines are perpendicular. There is 90 degrees. One line is like this, another line is this. This is 90 degrees. When the two lines are perpendicular or 90 degrees, then product of their slopes equal to minus 1. When the two straight lines are parallel, right? Then the slopes are equal. This is, you can take it as m. This you can take it as m2. Okay. Right? So this is what the straight line. Okay. Next one. Next pair of straight lines. Suppose there are two straight lines are there. Then this is the concept of pair of straight line. Then if this is a pair of straight line equation, ax square plus b 2hx square plus by square equal to 0. The pair of straight line passing through the origin means this, right? Then if the pair of straight line equation is given, then the theta, the angle is what? Tan inverse of modulus 2 into h square minus ab divided by a square. So remember these formulas. Then this is a condition for a pair of straight line modulus. I already told you this determinant is equal to 0 mean, right? If it is 0, then you can get the condition. This condition is equal to 0, then we say that three straight lines. You can use the condition for three straight lines. They are parallel, okay, or coplanar means then is equal to 0. So next one is a circle, right? Circle, just remember the equation of circle and the properties, center, diameter, right? All these, okay, concept. Then ellipse, parabola, hyperbola. We should know what is ellipse. Ellipse is the eccentricity is less than 0, eccentricity equal to 0 parabola, then eccentricity greater than 0 hyperbola. So remember these, right? The concept. This is an ellipse equation, right? These are properties of okay the parabola. Y square equal to 4ax, y square equal to minus 4ax. What is the vertex, focus, eccentricity, latus rectum? These are the things how to remember, right? Question may come from this. Okay? Right. So this is a hyperbola. I will study parabola, hyperbola, ellipse, all these things. Okay. Right. Okay. So now I covered, right? Here I covered first 5 topic today. So allotted we have 1 hour only. So in this 1 hour, I can cover this first topic, APGP permutation, matrices and their application, trigonometric complex number, then the fourth one, analytical geometry of the dimension. So today, okay, I covered these 4 topics, right? But we cannot do a problem, but I explain the concept. If you know the concept, you can do the problem, right? I'll share these concept your WhatsApp group, okay, later, right? So that's all today's session. Thank you, student. We'll meet you next class. Thank you.
Thank you, sir.
If you have any doubt, you just ask.
Yeah, thank you, Professor.